Intermediate Algebra for Statistics, Linear Inequalities and Systems of Linear Inequalities, Part 3. Lesson objective: use a system of linear inequalities and two variables to make estimates. Lesson objective. We'll begin with an example. Example 12. A person's life expectancy predicts how many remaining years the person will live. The age expectancies of U.S. females at birth and at age 20 years are shown in the table for various calendar years. Let L be equal to B of t be the life expectancy measured in years at birth, and L equal T of t be the life expectancy in years at age 20 years, both of U.S. females at t years since 1980. The linear regression models of B and T are, respectively, B of t equals 0.100t plus 77.65, and T of t equals 0.076t plus 58.96. Number 1. Find a system of linear inequalities that describes the life expectancies of U.S. females from 0 years through 20 years old from 1985 to 2010. Number 2. Graph the solution set of the system of inequalities that you found in Problem 1. Number 3. Estimate the life expectancies of U.S. females from 0 years through 20 years old in 2005. Solution. Number 1. The life expectancies must be less than or equal to the at-birth life expectancies, L less than or equal to 0.100t plus 77.65, and greater than or equal to the life expectancies at age 20 years, which has the inequality L is greater than or equal to 0.076t plus 58.96. We are seeking the life expectancies for the calendar years from 1985 through 2010, which that would be the number of years beyond 1985. T is greater than or equal to 5, and T is less than or equal to 30, which is 2010. So our system is L is less than or equal to 0.100t plus 77.65. T is greater than or equal to 5. L is greater than or equal to 0.076t plus 58.96. And lastly, T is less than or equal to 30. So we have 4 inequalities here. Number 2, this is our graph. Here's T is greater than or equal to 5. Here T is less than or equal to 30. It's going back this way. So we have these two boundaries. Here we have B of t, and it's less than, so that's going to go down below the line. And then we have T of t, and we want greater than or equal to, so that's going to go up. So we have this quadrilateral here, and that is our solution set. All the xy points in this area satisfies the system, makes all 4 inequalities true. Number 3. The life expectancies of U.S. females from 0 years through 20 years old in the calendar 2005 are represented by the vertical line segment above t equals 25 on the t-axis in the figure on the next slide. From this line segment we see that the life expectancies are between 60.86 years and 80.15 years inclusive. So in 2005 we have t is equal to 25. Let's look at the next slide. So here we have T of t, so when we substitute 25 in, we get back 60.86, and for the B of t, when we substitute 25 we get back 80.15. So this is the prediction when t is 25 or in 2005. Example 13. The National Collegiate Athletic Association, NCAA for short, regulates the lengths of baseball bats used by college baseball teams. The NCAA states that the length, measured in inches, of a bat minus the weight in ounces of a bat cannot exceed 3. Bats can be purchased at lengths from 26 to 34 inches. A. Write and graph a system of linear inequalities that describes the information given above. B. A sporting goods store sells a bat that is 31 inches long and weighs 25 ounces. Determine if this bat can be used by a player on a NCAA team. Solution: we will let X be equal to the length measured in inches of the bat and Y be the weight measured in ounces of the bat. From the given information, we can now write the following inequalities. X minus Y is less than or equal to 3, and that comes from the statement that the difference of the bat's length and the weight can be at most 3. So it can't be larger than 3, it has to be less than or equal to 3. X is greater than or equal to 26, that's the length of the bat must be at least 26 inches. X is less than or equal to 34. The length of the bat can be at most 34 inches. At most is less than or equal to. And Y is greater than or equal to 0. The weight of the bat cannot be a negative number. It has to weigh something. So part A. Our first step, we want to take X minus Y less than or equal to 3 and solve for Y. So our first step is to subtract X to both sides. We have negative Y is less than or equal to negative X plus 3. To isolate the Y, we divide by negative 1, and if you recall, when you divide by a negative number, you flip the inequality sign. So we have Y as greater than or equal to X minus 3. We have our second inequality, X is greater than or equal to 26. X is less than or equal to 34 is our third inequality. And last, Y is greater than or equal to 0. Based upon the inequalities, I am using the first quadrant to graph. Because we wanted numbers that were less than or equal to 34 on the x-axis and greater than or equal to 26 on the x-axis, I am going to scale my x-axis where each mark represents 5. So we have 5, this will be 10, 15, so on and so forth. I'm going to do the same for the y-axis. So each mark represents 5. So our first inequality, so I'm going to graph x equals 26. Greater than is area to the right. The next inequality, x is less than or equal to 34, looks like this. So here we have the overlap, so these values make both inequalities true. Next, we need to graph y as greater than or equal to x minus 3. So when y is 0, we substitute that in to the equation y equals x minus 3. So we have 0 equals x minus 3, and that means x is 3. So when x is 3, y is 0. So we graph that point. Next, when x is 26, on this line here, what's the value of y? So we substitute that into that equation, and we have 26 minus 3, which means y is equal to 23. So we have 2 points to determine this line. We connect them, and since we want greater than or equal to, color above the line, and we have this section. So this area here is the part that's been overlapped, and that is our solution set. Now to help us with part B, we should define this point. To figure out this coordinate, when x is 34, using y equals x minus 3, we have our y coordinate being equal to 31. The red section is the solution set for this system, and we see because the point 31, 25 is not in the solution set, the player will not be able to use the baseball bat on a NCAA team. Thanks for watching.